So in one of our last session, we discussed about the JVM. We discussed Java and also we discussed exception handling and so and so. But we discussed JVM up to some extent. Okay. So mainly how many parts in JVM? Very high level, 3 level, right? So what are those? Class loader, good. Memory area, very good. Done homework, right? Okay, cool. That's good. So now, so what we do is we load and we store and we execute, right? And then other than that, we have the garbage collector where do the cleanup work, right? So we load, we store and we execute. And also for the class loaders, we have 3 type of class loaders, right? So we have Bootstrap ClassLoader, and then we have extension ClassLoader. So after Java 9, they call this as a platform ClassLoader. After Java 9, right? And then you have application ClassLoader, also known as a system ClassLoader. Very good, great. Okay, and the memory area we divided into 5. First one, method area. Second one, heap, stack, PC register, also program counter, and native method area. Okay, great, super. So if you do homework like this, we can go deeper and deeper. So what the method area does is we load the class to the method area. So out of these are 1 per JVM. These are 1 per thread, right? So these are 1 per JVM, these are 1 per thread, okay? So and method area, what it does is it load the class and keep all the metadata information on the method area. Once you loaded the method area, and then heap is used to objects, so the objects, and stack is used to method and variable information, and the stack method stack trace, and the PC register current executions. Actually next execution to be exact, because what is next to, because what happens is when you get the bytecode, it carrying the instruction set, right? So technically speaking, you can say it has the current information as well, because it came from there. It's like a pointer, like not the pointer, but going through the instruction set. And then native method area we used to use the non-Java, right? These are completely non-Java, right? So non-Java. Example, if you get hash code and clone. So these methods are implemented using non-Java, right? So those are running through this one. So if it is a non-Java, PC register won't have any information. Why? Because PC register is there to hold the bytecode execution information, right? And then after that, we have execution engine. I think I missed to talk about something called JNI, right? Which called Java native interface. So what it does is it give information about the native methods into execution, right? So that's a JNI, give the information about the native method, right? So if you go from the beginning, so we have a class loader, we load, and then we create a heap, and then stack is used for this one, and the method memory area is what is dividing, and then we have execution engine which use the JNI Java naming interface, sorry, Java native interface. So what it does is it give information about the native method. Cool. Now we are going to zoom in, okay, because you did homework and you now you understand the first phase very well, so you remembered it. So now we are going to zoom in. Now if you get this one, okay, just a method area, class loader load the class. When the class loader load the class, it read those binary information, can say binary, it's a bytecode, it load in the bytecode, and it store all the information about the class. Okay. For example, fully qualified class name. What it means, from the package name to the fully qualified class name. Okay. So what are the things can generate a class file? I asked you to do a little experiment with the lambda. Create a program in a traditional way, create a program in anonymous in a class, and create a program in a lambda way. Have you done that? Okay. So what are the things create classes in Java? Class files. If it is an interface, it create a class file. Right? If it is a class, it create a class file. What else it create class file? Huh? No. What are the things generate class files when you compile? For interface, you get a class file. For a class, you get a class file. There's something else. If you create an enum, then still you get a class file. Enum, let's say some enum.java file, when you compile, you get a class file. Okay? So now it see whether it's a class or an enum or an interface or what. Right? And it store about the method information, especially about the modifiers, etc. Right? It has all these information. There are so many others, right? Variable information and all those information it going to store during the load. Okay, so where this is stored? In the method area. Then what it does is, this is very important, it create, right, if you draw heap here, heap is dedicated for store the objects. So what it does is, it create a class type object, right? So if the class is, let's say the class name is employee.java, so which came to employee.class, right, which come to employee.class, right? So now this class file, when you load, it is not, it create employee type object. That's a very misconception. It create an employee type object. No, there is something called active use for a class. There are 5 or 7 as I remember ways Java create an object for you. If you use a new keyword, if you use if you load it from a file, there are so 5 different ways it create a class. This is not a employee type object. What it does is it's a class type object, right? Type of the object is class. Why they created? So developers can get the information about this class. Okay, for example, in your code you can write something like this inside the main method, and I don't have to tell, this is standard main public static void main string args, right? So you can say class equal class dot for name employee, right? I don't exactly remember, it's something similar to this, okay? And now you can say class dot get declared method. So now it return all the methods belongs to this employee class. You can observe the class, right? We need a reflection framework to do it. You can observe the class. You can see what are the variables, what are the methods, what are the constructors available. You can see everything about the class. Okay, so this may not be the exact keywords and the method name, but you can do it. So now that means it's a class type. It is not a employee type, right? Employee type create when you use a new keyword, or if you use the serializers. We are going to discuss what are the ways Java can create an object for you. Okay, so now see this one. Now you are inside the code. Now its loading is complete. Let's assume that loading is complete. Now you have employee emp equal new employee. Okay, so when I write this, I'm lazy to write the employee as a emp. The right practice is variable name should be the class name, first letter simple. Okay, but since I'm lazy to write, I'm saying emp, new employee. Now what happened? Now what happened, other than this one, right? Other than this one, let's say this is a class type object, right? So then other one being created called employee, right? Other one being created for employee. Let's say this is on a memory address 100. Just assume. Okay, let's say this is on a memory address 50. Okay, now you don't have this one. So now we don't have anything, right? So inside the main method, employee emp equal new employee. Okay, so now when JVM see this statement, what it does is it trying to create a new object. That means it going to actively use the employee class, which mean what it trigger? What trigger? ClassLoader. ClassLoader come and say, okay, he is looking for employee class. I need to load it. It go to the file system and take the file and load. Right? So by the time when it load, what happens? It load all the meta information to the method area. You're following me, right? Method area, and then create a class type object. And then since it's trying to create object, it create an employee object. Correct? You following me? Now what it does is, I have other statement, employee emp2 equal new employee. So now tell me what are the steps happens. So JVM sees, right? So the executor sees, okay, I want to create other employee object. What it does? It go and load the class. Does it load the class and create the class object? No, it doesn't. Why? This is already being created. This is already being created, right? But it will create employee type second object, probably in the memory address 200. Okay, it will create second object. Now see this one. So I'm going to write something like this under this, right? So class C equal class dot for name employee. Or you can do something else. Okay, so what you can do is you can do something like this: emp dot get class, right? We assign to class type object C, right? Then class type object C2 we assign emp2 dot get class. Okay, and we write a statement here emp equal emp2. We are going to print this, and also we are going to print C equal C2. What it will print? True, 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 false, false, true, or false, false? False, true. False, true. Yeah. Why? Because these two doesn't equal, it created a new object. Equal sign check, not the content, but the reference. So, but C2 is same. Why? Because it's referring to the same class. Okay. So, that is all about loading. Right? That is all about loading. Okay. Okay. So, now class is loaded. Okay. Loaded is mean like not completed still. So, there is a process called linking. Okay, there is a process called linking. Linking mainly has 3 steps, right? Verification, preparation, and resolution. Okay, verification, preparation, and resolution. Verification is, there is something called bytecode verifier, right? There is something called bytecode verifier. What the bytecode verifier does is whether your class is a really valid Java class. Okay, really valid Java class. How operating systems or anyway identify is a text file or is a PDF file or it's a PNG file or a JPG, how it does? No. Extension is something created later on by Windows. If you go to Linux operating system, you don't need extension. It can figure it out. There is something called magic byte. First 4 bytes in the file is referred to that. For a Java class file, the magic byte is this. It's a hex value. So it starts with this. Okay. So that is what James Gosling and his team is created as a magic byte. What is this? Just if you separate here, Cafe Babe, it's a Java. Okay, so this is the magic byte, right? Magic number. So first, what it does is it refer, not the magic byte, it's a magic number. So what it does is it refer whether this is a valid class file, whether it's a first it say it's a Java class file, right? And then it going to check so many other things, whether this is violating any access modifier validation. For example, is it respecting to private, public, protected, all those access modifiers? Whether it is trying to access any illegal memory areas. You cannot ask it to write any illegal memory area. Whether it's jumping to branches where execution engine cannot jump. For example, because if you go forward and if you suddenly ask it to jump somewhere else, then it cannot do it. Okay, so it does all those verification. There are 4-5 things it check, right? So this is class format, whether this is a valid, and there are security checks in the sense whether it's trying to go for those illegal memory areas or what. And I don't remember exactly, but you can Google and find out. There are 5 things it check, right? 5 or 6 things it check. So if one of those fail, it says bytecode verify error. it throws the verify error. Okay, it throws verify error. So verify error, what it does is, what it tells if you ever get a verify error, so that means your class file is modified outside the compiler. That's the most probably can happen. Why? Because if it is trying to access illegal memory area or something, if it is trying to violate the respecting of the access modifiers, then compiler won't compile. Okay, how this is possible to happen? Once the compiler compile, some other tool go and modify the bytecode. That is the only possible way, because otherwise compiler will break. If you are trying to access a private variable in an unnecessary way, somewhere you know visible, compiler says you don't have visibility for this one. If you are trying to break the flow, it says you cannot do it, unreachable code, right? And if you try to refer something which is protected somewhere, it says no, you cannot do it, right? So but here you generate the bytecode and you tamper the bytecode outside the compiler, and then it's going to catch it. This is mainly for prevention. So then virus or some harmful software or some sort of a tools, Trojans, they cannot go and update the bytecode, because the moment they do so, the runtime, it will catch it saying, I cannot load this class file because verification is failed. Okay? So that is the first phase, verify. So you can put a like note saying the Google and see what are the things it does in this verification. I mean, things are all those, but those are categorized. Like for example, access modifier validation, format validation, integrity validation, security, something like that. I don't exactly remember what are those systems. So just Google and see. But even after that, you don't have to remember it. Okay, don't try to memorize. Okay, these are the things. Otherwise, you're going to teach JVM to someone. You don't have to. But you have to have a global, like what I did, right? So I know what exactly verification stages does, but I don't remember which section that each one goes. Okay, you don't have to remember it, but what you need to is remember what it does. Right? Verification is pass. Okay. So now it go to the preparation. What the preparation does is, if your class has any static variables, it assigns the default values, class level static variables. Default value doesn't mean, let's say you have a code something like this, static int x equal 20. Let's say something like this. When the JV after load verifier success, when JVM sees this one, what it does is it creates the x and assign 0 to it. That's a default value mean. Every primitive type variable or every variable has a default value. If it is a primitive type, for example, if it is an int, it's a 0. Right? If it is a double, it's a 0.0. Okay? If it is a boolean, it's a false. If it's an object, it's a null. Okay? So what it does is it assigns this default value. It does not assign the real values. It does not assign this part. It does not do this part. Okay? So that is preparation. So now what we did, we link, this is a part of a linking, right? Loading, and now it's linking. So during the linking, what it does is, it is verify. If the verify fails, it prepare this, right? It prepare something. It's like a patient is taking into surgery where they don't cut outside the theater, right? So, but they just do the marking. Okay, these are the areas incision to be made. They just set it and send inside, right? So that is what this preparation does. Is it really preparing your variables? Okay. Okay. Now resolution is the tricky part to understand. Okay, resolution is the tricky part to understand. Let's say I have a code like this. Okay, I have a code like this, right? Class employee. Okay, it has a public void method print. Okay, it has string. No, it has project p equal new project. Okay, now just assume there's a project R somewhere. String s equal new string. I understand you don't have to do it. Hello. Big integer bi equal new big integer, something like this. Okay, tell me how many classes are being loaded. If this program is executed, how many classes are being loaded? Forget about that you have to have a main method and somewhere in the main method class, forget that part. By looking at this code, how many classes are being loaded? I'm going to give a gift if you give a proper answer, the right answer. Shankar, how many? One. How many? Still loading? The machine is very slow. One. Four. One. Three. Four. Four. Two. Okay. One is obviously wrong. Two also wrong. The problem is a 3 or 4. Okay. So you said, what? You said 3, right? You said 4. What are the 4? Employee. Okay. 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 4. But answer is wrong. Why? Anyone? Anyone? Why answer is wrong? See, this is the problem. You understand, you learn the basics, but you forget the basics. We learned while ago how the loading works. No. The string is a class, it's going to load. Anyone else? We learn like a mantra. When you load the class, it loaded parents. So that means who's going to load? Who's parent? Huh? Who's a godfather? Who's a godfather for? Any class? No. Huh? Any class in Java? Who is a parent? Who is a super parent? Object. Anything coming from object. Any class is a godfather. Godfather is not that real meaning, but he's a father. Super parent. Okay. So when the first class load, obviously object going to load. Okay. So how many? Minimum 5. Huh? There are more to go when we load these classes. There are, because big integer is coming with a number. Okay. So likewise there are more, but minimum 5. Minimum 5 by looking at this code. Right? But if you go deeper, there are 4 more classes going to load. Okay. Now what it does is this, right? So now let's say this is our heap. Okay, so this is our heap. Just because I always use a black color, it doesn't mean heap is black, huh? Right? So now it create employee, probably memory variable 100, right? And the project 200, string 300, big integer 400, object probably 50. Okay, so now these are already loaded into the heap. Okay, what the resolution does is, because these name for us, for developers, those are human readable. Okay, the machine don't care whether it's a project or an employee or a human or an animal, it doesn't care. What the resolution does is, it replaces these reference, these names with the its all memory references. So this will replace this, right? So this will replace this, right? So instead of that, it will say memory address 400. Okay, the memory address 400 is an example, so don't take it that way, but it is replacing with these references, right? So string replaced to this one, and the employee is replaced to this one. That is what resolution. The resolution mean it literally replacing your whatever the references or the names you given here with its own memory references, which is loaded, created by the previous steps. Understand? So now we have class loader. Class loader does this loading, linking, and initialization. Linking is divided into three parts: verification, preparation, resolution. Verification, verify whether it's a real class file and so many others. Preparation, setting the default value to static variables, and the resolution is replacing the replacing your names literal given into the its own memory references. So these are called, whatever we call symbolic name, right? So your symbols is replacing with the memory address. And this is not only for this, so this does for a classes, resolution does for a classes, methods, and variables. For all, it does this replacement, even for the methods. Anything you have a symbolic name, it's replacing. So if someone asks, do you need to know this much of JVM in detail to write Java code? No. Okay, to become a Java engineer or Java developer, you don't need to know JVM in this detail. But to become a software engineer, you need to know. Why? Because at some point, you're going to deal with the Java-based system. Okay, so now you can think, okay, I'm doing AI, ML, or whatever the things coming on. But I guarantee at somewhere, JVM going to cross your path. Okay, so it's better have an idea. So now, what we have, loading, linking, and initialization. So now we done the loading, we done the linking, and now we need to do the initialization. Okay, initialization is quite simple compared to other phases. What it does is, remember, okay, where we did the default value assignment? The preparation stage. What it does is, now that prepared patient is now came to the theater. So now we do here is the assign given value. Right? Assign the given value. That is mainly the initialization mean. Okay, initialization is nothing but, so when in the preparation stage, it given the default value. So now it gives the real value, which deserved by the variable. Okay, which deserved by the variable. And so now first one is that, right? So now since we are done, I'm going to use the board here, right? So what it does is assign given value, right? In a Java classes, you can write something called static block. Okay, you can write something called static block. This is how it goes, right? You can have something called static, and then you can write something on inside that, right? So string.out.println loaded. Okay, loaded. So how this behave is changed from some Java version, but we are going to discuss the default behavior. So what it does is it execute the static block, right? Execute the static block. Okay, and also it making sure parent class loaded first, right? This stage is the where it's making sure the parent class is already loaded to move forward. And also this is thread safe, which means it's guaranteed only one thread can run the initialization stage. Okay, so this static block is little bit changed time to time. For example, if you say previous example, employee equal new employee, right? And then employee E2 equal new employee, right? And we discuss when you do the first one, what it does is it load to the method area and it create a class type object and it create the employee object. But when you do the second one, it doesn't create that class type object. That is why when we try C1 to C2, this returns true, right? But E to E2, it returns false. Why? Because it's using the same class, it doesn't create again. So this static block is treated similar because it is executing on the initialization stage. So if you put something on the static block, it will load one, it will print one time. Okay, there is a block you can write without a static also. It's just a block, right? But constructor it fire every time you create object, right? Constructor it fire every time you create object, but this one time. There was a little change to this static block and the standard blocks, how it execution and execution order, which we are going to discuss, because we are going to discuss some like how Java behave little differently than usual. Okay, kind of a tricky places in Java. So we are going to discuss taking one particular day on those weird Java, right? So there I'll explain. So this is static block and the block is executing differently. But for now you can think, so this is the static block execution. So this is everything what's happening in the initialization stage. Okay, so now what we covered, we did the loading and we did the linking and did the initialization. So loading, we did all those getting the fully qualified name and everything in the method area. And the linking, we did the verification, preparation, and the resolution. So now values are assigned, default values are assigned. So now it is passed to the initialization. So initialization, it assigns the proper values and execute the static blocks, and now it's ready to go stage. What are the class loaders we have? Bootstrap, extension, and then application. Application also known as system, and after Java 9, this known as a platform class loaders. Okay. Now they follow something called delegation model. Right? They follow something called delegation model. This is a very clever design, very clever solution to bigger problem. Okay, this is a very clever solution to bigger problem. See how it works. So Bootstrap ClassLoader, what it mainly load is rt.jar, because rt.jar is carrying all the core classes you need. Right? In your JRA, you can find something called rt.jar. So this is carrying almost all core component. Right? So what it does is, from Java home, this has to be full capital, huh? Java home, lib directory, you have rt.jar and few other Java files. It load in this Bootstrap ClassLoader. So this is, though we call this as a system class loader, mainly almost all the files which you need to run Java is loading there. Right? So that is what is leading to his previous question also. Is really string is loading from here. But we are going to discuss this later. We are not going to touch that now. Now, extension class loader, what it does is, it load classes from, right? It load classes from Java home lib ext directory. Right? Ext directory. So if there is any classes here, it's loading from there. Okay? An application class loader, what it does is, it loads the classes from class path. When you execute a Java code, and that's why I told you in that previous assignment, the 3 classes and anonymous and write on the same directory, right? So next time we are going to extend that to move these classes to different directories. So now you are going to say it's going to complain your class is not there. So now you need to send the cp -cp into your execution command so that you can add new class paths. Right? You can add new class path. So what the class this does is, it load probably your applications, mainly your project. So that is loading from here. Okay. What the delegate, okay, don't get this confused. I'm going to explain the concept little complicated. Don't get this confused. What the delegation model mean, okay, because what I'm going to tell now, I'm going to change in a little bit because of a very valid reason. So don't get confused, follow me. What the delegation model mean, when a particular class is needed, right, what the class loader does is, take the class from your hard drive or a storage, right, and load into the, where? Which area? Method area. Okay. What the class loader does is, take your class from your hard drive and load it into the method area. Okay. So first it's going to ask, I'm going to change this in a while. First it's going to ask application class loader, hey, just load this class. Let's say employee.java, employee.class file. Hey, can you load this? Okay? Application class loader says, wait a minute, I need to check with my boss. So it go and ask extension class loader, hey, can you load the employee.class? So it go and check in this location, do I have employee.class? It doesn't. Okay, so now it says, actually it doesn't go and check, sorry. So when it come here, it says, wait, I want to ask from my boss, can you load this employee.class? Now Bootstrap ClassLoader go and check this location, can it load the employee.class? Is it there? No. So it says, sorry, I cannot load this. It's all yours now. Okay? So now extension class loader or a platform class loader see this location, can I load the employee.class? Can it load? No. It says, sorry, I cannot do it, now it's all yours. Okay? Now it see class path, can I load it? Yes, it will load. This is called delegation model. It delegating to its superiors, and when it cannot do it, it pass it back. It pass it back. Now, let's simulate one more time. In your example, directory 1 has employee, we get a human and man something, right? Human, which is an interface. And other directory D1, other directory D2, you have a man class, which is a class. And D3, you have application, which is class. Now when you run the program from here, this directory, what it sees is this class. So now in your main method, what you have, human h equal new man. Now it's going to load man class. Understand? Man class in which directory? D2. Now application class is here. So class path is that. So now it says, hey, can you load man.class? Extension class loader. Extension class loader asks Bootstrap, hey Bootstrap, can you load man.class? Bootstrap says, no, I don't have it. It's yours. So now extension class loader, see, can I load the man.class? Can? No. So it passed to application class loader or a system class loader to load the man.class. Can it load? No. Why? Because it's not there. So now it throws class not found exception. Class not found exception. When you see the class not found exception in Java, so that means your class loader cannot figure out where the class is. There is something coming, sometimes it's coming from class def found exception is a very different scenario. Right? A very different scenario, but that's how it works. It delegate and come back. Now the $1 million question is, when it come to here, when it directly can load the class, why it go all the way and come back? Right? So every time what we saw is, the application class loader is responsible, but it talk to the boss and it talk to the boss and it come back. That's what I said. This is a very clever solution to a bigger problem. The reason is this. These are system classes, right? Object, number, all those, the java.lang, what is coming in system classes. If you create your own class called java.lang.object, here, your own custom class, when you're trying to load that, it will directly load it if you are going in a direct loading. Rather what it does is, it's asking, do you know this class? So that prevent any attacker or any hacker or anyone overriding system classes. That prevent it overriding system classes. Why? If the class is supposed to load by the bootstrap, then you never can load this from here. You never can load this from here. Okay? You never can do it. So now what you need to do is, there is a way you can get which class loader used to load this particular class. You can print it. Okay? You can print it. But if it's a bootstrap class loader, it print null. Right? If it's a bootstrap class loader, it print null. Right? So why out of these class loaders, bootstrap class loader is developed using C and C++. Right? So extension class loader developed using Java, and application class loader also developed using Java. Okay? So therefore, when you given a class and ask JVM, hey, who did you use to load this? If it's a bootstrap, it's a null. Why? Because Java cannot interpret it, because it's a non-Java implementation. Java cannot interpret it. But these two you will tell. Now here is what you need to do. Okay? Understand this assignment. You create an employee.class, write a main method inside that, don't have multiple classes, and run this. And print what is the class loader it used. It will tell it used by application class loader. Now copy that employee.class file here. Right? And now ask to load it. And ask which class loader is used it. Now copy it to here. Okay? And tell me what's happening in each step. Whether is honor your, when you copy, even though you have it in here, does it load from somewhere else, or it will not load? Okay, if it's loading and not loading, then we can discuss why that's happening. Okay, so understand what you need to do? Write app. So you have two classes, application.java and employee.java. Right? Application has a main method, and you call them, you create an employee object. Right? Employee class, you transport different places and see whether class loader is changing based on the type place you put. Understand? You got this delegation model, and you got why you need it. Right? Why you need it? Because it preventing we overriding Java own implementations. Java core classes we cannot override because it's already loaded. Now I told I'm going to change this. What I said. Now don't think, right? Don't have an idea. Always that request is come to application class loader. For example, why? Right? Because let's say, for example, you need to load something like a rt.jar, which is a core class. Right? So now, if this request is coming to application class loader written on what? Java. So that means it's a Java class. So Java class means that class has to load. So that class to load, you have to have a class loader. That class loader will be application class loader. So application class loader to work, you need that class. That class is a, so you become a hen and egg problem. Okay, you have a hen and egg problem. You cannot do it. So because these are implemented using Java. So therefore, for core Java classes, JVM knows exactly hit to the bootstrap. Just to avoid this hen and egg problem. You understand, right? Because this is a Java implementation. Every Java implementation is a class. That class need to load to the memory. Right? It cannot load to the memory because you need a class loader. Class loader itself is Java. So that is why it is coming from here. So these are implemented. So main core classes, this directly hit here. Okay, it is not always everything is coming from here. So as I remember, this is application class loader is sun dot miss dot launcher dot application class loader. As I remember is that, but not sure, right? So this is the class file. This is the class file. This application class loader is implemented, right? So now if someone is calling this, you need to load this class. To load this class, you need the class loader. So this is loading from here. Right, now there is something called, the fourth one called custom class loader. Okay, custom class loader. Now, whether it's a bootstrap or an extension or an application, class loader has a behavior. It load the class only one time. When the initial load only, class loader fires. But if you need to change its behavior, for example, we learn in the web services session, right? So what we do is we have a separate container. We took the Tomcat as a container, right? So now we load the class file into that. Tomcat is the original Java process JVM which is running, right? So it's running the classes inside that. So that means it need to execute the classes, it need to load the classes dynamically, not in one time. For example, let's say you did some changes to web application and you redeploy, called hot deployment, right? Now class need to load again, right? So let's say you have employee.class, employee.class, right? This has a method 1 and method 2, right? Now this is run on the somewhere in your JVM is running already. Now you did a change, you had M3, right? Now until you stop the JVM and run again, this M3 will not affected. But in case if you need to get this available on the fly without unloading it, then you need the custom class loader, because you need to change the way of loading happens. Okay, that's a one. The second one, something like Mockito or JUnit, those testing framework, they kind of are mocking things because they adding something which doesn't exist in your class file on the runtime. For example, if you want to talk to a database in the unit test running, you don't talk to the real database. Some people write in test case like that, that's completely wrong, right? You don't write test cases. When the test case runs, you hit to the database, right? Let's say you are calling like M3 or some sort of a third party API, right? Then you don't call that API while you're running the code test. So what you do is you mock it. To mock it, when the program is running, the runtime, they need to inject some portion to your bytecode. Okay, so inject means don't get the now it failed the verifier. What I mean, it properly compile instead of the previous employee.class, we just need to replace it and reload it to the method area. Understand? So to do that, we need something like this, right? Custom class loader. And if someone asks why you need a custom class loader, if you need to change the behavior of your class, right? If you need to change the behavior of your class. So other one is, other than that previous assignment, you need to create a custom class loader, right? And you need to use the employee.class. You need to get the class object dot get class and print the hash value, right? And you reload the class and print it again. So now ideally it should be different, because when you print that hash, it is a hash value of the object it being created, right? So it will different. So that is the custom class loader. Custom class loaders, what are the use cases? If you need hot deployment, right, you need to runtime activate. And also there is other thing, very important part. So class loader, we explained, class loader doing what? Loading class from where? Loading class from hard drive into the method area. But if you need to, for some reason, store this class file in a database, in another HTTP service, you can have a requirement. your classes files are in the database. So then easiness is, while the system is going, you can replace the class file. If you need to load the class file from other sources than the file system, then again you need the custom class loader, because the standard class loader, default class loader, don't understand to load class from anywhere else other than the file system. Okay, right? So those are the class loaders. So now we kind of completed major part of the JVM, right? We understand what the JVM is, and then we need to go deep dive. Like you remember the first day today, so if you remember this on the next day, so you are going to deep dive into heap and the threads and all other things, how those really internally works. As I said, you don't need all this detail to write Java code, but you need when you want a real software engineer. Okay.